Hello everyone. Now I am going to explain you about brick sort algorithm. First of all, let us see what is brick sort algorithm. The brick sort algorithm is also known as odd even sort algorithm. It is a simple sorting technique in which it arranges the elements in a more efficient manner. This method resembles the way the bricks are orderly stacked to build a wall. Now, let's see the example part of this brick sort algorithm for the better understanding. Let's move into the example part. Here in this example, in an array, we consider elements as 2, 3, 7, 5, 1, 8, 6 and 4. Before going to solve this example, I would like to say that in this brick sort algorithm, there are totally two phases. One phase is odd phase, another phase is even phase. The blue boxes indicates odd index values and grey boxes indicates even index values. Now, the first phase is odd phase. That means in this phase we will sort all the odd index values only. The first odd index place value is 2 and next odd index is 7. Next odd index is 1. Next odd index is 6. Now, we will sort all these odd index values by comparing with its successor element. Now, if the given element that is considered odd index element is less than the successor element, then no swapping is required. If the odd index value is greater than the successor element, swapping should be done. Now let's move into the first phase sorting. The first odd index value is 2 and its successor element is 3. As 2 is less than 3, no swapping is required. Next odd index is 7 and its successor element is 5. As 7 is greater than 5, swapping should be done. Next odd index value is 1 and its successor element is 8. As 1 is less than 8, swapping is not required. Next odd index value is 6 and its successor element is 4. As 6 is greater than 4, swapping should be done. Till now, first phase of odd index sorting is completed. Now, let's move into the other phase. Second phase is even phase. Similar to the first phase, here we will sort all the even index values. The first even index value is 3. Next even index value is 7. Next even index value is 8. Next even index value is 6. Similar to the first phase, here also we will check that if the even index value is less than the successor element. If this condition is satisfied, swapping is not required. If the given even element index is greater than the successor element, swapping should be done. Now let's move into the second phase. The first even index value is 3 and its successor element is 5. As 3 is less than 5, no swapping is done. Next even index is 7 and its successor element is 1. As 7 is greater than 1, swapping should be done. Next even index value is 8 and its successor element is 4. As 8 is greater than 4, swapping should be done. Next even index value is 6. But to compare with the other element, there is no successor element present. Therefore, we can't determine it. Therefore, no swapping is possible in this case. Up to now, second phase, that is even phase sorting, is completed. Now let's move into the odd phase, that is third phase. In this third phase, similar to the first phase, we will sort all the odd index place values. The first odd index is 2 and its successor element is 3. As 2 is less than 3, no swapping is done. Next odd index is 5 and its successor element is 1. 5 is greater than 1, therefore swapping should be done. Next odd index is 7 and its successor element is 4. 7 is greater than 4, therefore swapping should be done. Next odd index is 8 and its successor element is 6. 8 is greater than 6, therefore swapping should be done. Up to now, third phase, that is odd phase sorting, is completed. Now let's move into the next phase. The fourth phase is even phase. Similar to the second phase, here we will sort all the even index values. The first even index is 3 and its successor element is 1. As 3 is greater than 1, swapping should be done. Next even index is 5 and its successor element is 4. As 5 is greater than 4, swapping should be done. Next even index is 7 and its successor element is 6. 7 is greater than 6, therefore swapping should be done. Next your index is 8, but to swap or to compare there is no successor element. Till now, fourth phase, that is even phase sorting, is completed. Now before going into the fifth phase, that is odd phase, here the first odd index value is 2 and its current and its successor element is 1. As 2 is greater than 1, swapping should be done in the fifth phase. Now finally, in this fifth phase, that is odd phase, all the elements are now sorted. In this way, we will use the brick sort algorithm for sorting all the elements in an array. Now let's move into the pseudocode part of this brick sort. The pseudocode part of this brick sort looks like this. Now I would like to show you the code of brick sort algorithm in C++. I will just show you the code and explain how it works. As we all know that the code begins with the inclusion of IO stream, which allows inputs and output operations. Now the odd even sort is defined, which takes an integer array and size of n as parameters. Inside the odd even sort, there is a while loop that has an array elements continues till the array elements get sorted, and boolean variable is initially set to false. Now inside the while loop there are totally two for loops. The first for loop indicates for odd index values and next for loop indicates for even index values. Now let's move into the first for loop. Here initially the value is initialized to 1 and after each and every iteration it gets incremented by 2. Now it checks for the condition. The condition is if whether the current element is greater than the successor element. If this condition gets satisfied, it swaps the elements and sets inserted variable to false. Till now the first for loop for odd phase is completed. Now let's move into the next for loop, that is for even index values. Here initially it is initialized to 0 and after each and every iteration it gets incremented by 2. Now similar to the first for loop, it also checks for the condition. The condition is whether if the current element is greater than the successor element. If the condition is true, it swaps the elements and sets the variables to false. Now if no swap occurs, it means that the array is sorted. Now the variable remains to true and while loop gets terminated. Now array A is initialized with some values which are unsorted integers, that is 2, 3, 7, 5, 1, 8, 6 and 4. Size of array n is calculated using the size operator, which determines number of bytes occupied by array and divided by the size of array. Now the elements get sorted after sorting. Now after sorting, a for loop is used to print the sorted elements of the array, and finally the main function returns 0, which indicates successful execution of the program. Now I hope that you understand how the sorting algorithm works. Now I would like to say and share time complexities of the brick sort algorithm. Time complexity analysis for brick sort algorithm is big of n square in the worst case. This is because it involves multiple passes through the array, each of which has a complexity of big of n, where n is the number of elements in an array. However, in practice, it may perform better than other big of n square sorting algorithms due to its adaptability to partially sorted arrays. In this way, brick sort algorithm is useful for sorting the elements in an array in a structured and detailed way.